Today's topic is buoyancy and Archimedes principle. Let us start this discussion with a simple demonstration. Observe this demonstration closely. I have in my hand an iron rod. Now, when this iron rod is suspended from a spring balance, the weight of the iron rod is indicated here. It's about 50 grams. What happens when I immerse the iron rod inside a jar of water? You can see that the weight shown by the spring balance is now close to about 40 grams. So the weight of the iron rod in air was about 50, and when immersed in water reduced to about 40. Why did the weight reduce when the object was immersed in water? Remember this demonstration while we do the rest of the discussion. A good starting point to understand buoyancy is to understand the concept of pressure. So let us start by doing that. Now there is this boy who's swimming. He is at a certain depth below the surface of the water. Let us call it D. The weight of the water above him will exert a force on the boy. This force is exerted on all parts of his body. And how much water is above him will be determined by how deep this boy is. So the pressure, which is the force per unit area experienced by the boy, depends on how much water there is above him when he swims. The greater the amount of water, the greater the pressure he will experience. What about another boy who's at a different depth? As this boy goes deeper, you can see clearly that this depth is greater than this depth. Who experiences the greater pressure? This boy here has a lot more water above him as he swims than this other boy. So the pressure experienced by this boy is much greater. So the pressure increases as depth increases, or simply we can write it as pressure is directly proportional to D, which is depth. So this is something you have to remember while we do the rest of the discussion. Now remember what happened to the iron rod. The iron rod, when I weighed it, was about 50 grams, but when it was suspended in water, it appeared to reduce by 10 grams and the weight was only about 40 grams. Why did that happen? Observe what happens to this object that we have placed in a tank of water. So we have a large tank of water and in it we place an object. Now, this object experiences pressure on all the sides. A cuboid will have 6 sides or 6 faces, and all these 6 sides will experience pressure because of the weight of the water above it. The water exerts pressure on all the sides of the object. Let us look at this pressure closely and analyze the pressure to understand the reason for buoyancy. Now, let us first consider this pair of sides. There is one side here and another side on the opposite surface. These two sides experience an equal and opposite force and therefore can be said to be cancelled. Similarly, these two sides also experience equal and opposite forces and can be said to be cancelled. What about this pair of sides? We have here the top surface and we have here the bottom surface. Are the pressures experienced by the top and bottom surfaces the same? They are not, because the top surface is at a certain depth and the bottom surface is at a much greater depth. And remember, we have already discussed that pressure depends on the depth. Greater the depth, greater the pressure. So the top surface experiences less pressure and therefore less force than the bottom surface. The difference in the depths between the top and the bottom creates a smaller force on the top and a greater force on the bottom surface. Since the force on the bottom surface is greater than the force on the top, we can call it FB greater than FT. This creates a net upward force. And what is the magnitude of the force? The magnitude of the force is nothing but FB minus FT in the upward direction. FB is greater than FT, therefore the net force is in the upward direction. And this net force is what we call buoyancy. This is what we call buoyancy. We discussed the cause for buoyancy. Let us understand how much force is exerted. The force of buoyancy, how much is it? It is equal to the weight of the water or liquid displaced. Now, what does that mean? Any object which is immersed in a liquid, water or any other liquid, will displace some of the liquid because the object occupies space, and when it is immersed in the liquid, some of the liquid is displaced. So the amount of buoyant force experienced by the object is equal to the weight of the liquid displaced, and that is what is called Archimedes principle. So the force of buoyancy is equal to the weight of the liquid displaced. This is of course named after Archimedes, the famous Greek mathematician and philosopher who discovered this principle. Now there are some very common misconceptions that I would like to clear. When you talk about whether an object will float or sink, how do you decide that? Remember, the size, shape, weight of the object do not matter. What matters is the density of the object and density of the liquid. Let us understand this in some detail. If we have an object, this object is immersed in a tank of liquid. Let us call the density of the liquid as dl, and let us call density of the object as dO. Of course, these are two different materials. The object has a certain density and the liquid has a certain other density. So what happens is, if the density of the object is greater than the density of the liquid, then the object sinks. When the density of the liquid is greater than the density of the object, object floats. And this can be determined only by comparing densities. The size, shape, weight of the object do not matter. Now, there is a third condition which is possible where these two are equal. What happens in this situation? Well, I do not want to give you the answer right away. This is something for you to think about. What happens when the density of the object is equal to the density of the liquid? This is for you to try and figure out. Continuing the discussion, let us summarize that you cannot say that an object is heavy and therefore it will sink in water. It depends on the density of the liquid, water, and density of the object. You cannot say that an object is light and therefore it will float. That would be wrong as well, because a pin is light, but it will sink because of the density of the pin. Similarly, you cannot say that object A is much smaller than object B, and therefore object A will float, object B will sink. A pin is much smaller than a boat, but a boat floats and a pin sinks. Remember, only two things matter: the density of the object and the density of the liquid. Let us do a couple of simple demonstrations to understand this concept even better. We continue our demonstration with the same iron rod. Remember, the weight of the iron rod was about 50 grams. Now, earlier, I immersed it in water and showed to you that the weight seems to reduce to about 40 grams. What if I immerse the same rod in a different liquid? Observe what happens. Here, the weight appears to be even lower than 40 grams. It's about 35 grams. So when the rod was immersed in water, the weight appeared to be about 40 grams. When the rod was immersed in a different liquid, the weight of the rod appeared to reduce even further. What would explain this? Water causes a force of buoyancy on the rod, and therefore the weight seems to reduce. The other liquid is more dense than water and therefore exerts a greater force of buoyancy, and therefore the rod appears to be lighter when immersed in the second liquid. So you can conclude that the density of the second liquid is higher than water. One more simple demonstration before we conclude this class. I have here some water in this jar. If I place an egg in this water, you can see that it sinks to the bottom. And we have already discussed that you can conclude that the density of the egg is more than the density of water, and that is why it sinks. What if we replace the water with a different liquid? What happens then? What I have done now is replace water with sugar solution. And when I drop the egg inside this jar, the egg floats. So egg sank to the bottom in plain water, but is floating at the surface in sugar water. What does this tell you? The density of the egg was greater than the density of plain water. So that is why the egg sank to the bottom. But when water was replaced by sugar solution, the density of sugar solution was greater than the density of the egg. So now the egg was floating. So I hope these simple demonstrations made the concept of buoyancy clear to all of you. Let us end this class with one final point. This is the famous question that Archimedes was asked to answer by his king. His king had his king had a crown made of gold. Now, that crown was supposed to be made of pure gold, but the king began to worry that the person who made the crown had cheated the king and put some copper instead. So Archimedes was given the task of finding out whether the crown was made of pure gold or not. So I leave the same question to you. Let us have two crowns which look the same and have the same identical weight. The problem for you is to find out which one is 100% gold and which one has some copper mixed in it without in any way damaging the crowns. Archimedes did it many hundreds of years ago. I'm sure you can too. So give it a shot. In conclusion, remember, anyone who stops learning is old. Anyone who keeps learning stays young. So keep learning. I hope you enjoyed this session on buoyancy. Thank you for watching.